Right, today we're going to be looking at inverse proportion, and what is important to note is that with inverse proportion, just like direct proportion, is we're going to need to find a constant of proportionality. So if we're told, like in this question, that y varies inversely with p, if you just use the proportion symbol, y is directly proportional, well, inverse means we put 1 over p. And to turn that into an equation, that means y will equal something, some multiple, times by 1 over p. That's my constant of proportionality. That's what makes it proportional to the inverse of 1 over p. And that is better written. If you times this out, you get k over p. Now, that is not my equation because I've got this k that I need to find, and I've given these initial conditions to find k. So I'm told that y equals 2 when p equals 5. So let's put those values in. So y equals 2, put it in there. We don't know, we're trying to find k, the constant of proportionality, and p equals 5, so put that in there. And that tells us that k is equal to 10. So in this expression, k must equals 10. And we finish this question when we say that y equals 10 over p. That's my formula connecting y and p. Okay, our next question is doing similarly what we did in direct proportion, is we now got to look at things being inversely proportional to other functions. So we're going to do z squared here. So I'm going to miss out the proportion symbol now and just go into equals k over z squared. Just shortcut all those ideas that we had before. All right. Now we know that x equals 3, where z equals 5. So put those in. So x equals 3, put that in there. We're looking for the constant proportionality k, and z equals 5, so we have 5 squared, which is 25 times 3. Gives me 75 for k. So therefore, as k equals 75, I'm going to make x equal to 75 over z squared is my formula for this. Now, when doing these questions, a lot of students make the mistake of just writing x equals k over z for inverse proportion because they see the inverse proportion but forget about the squared bit. So make sure you don't forget about the squared bit when doing these questions. Right, just one more of that type. Let's do a cube root one. So p varies inversely with the cube root of p. So we know that p is going to equal to some constant divided by the cube root of p. Varies inversely. The word inverse means this bit's going to go on the bottom of our fraction. So cube root of q. We're told p equals 1 and we're told q equals 64. So put them in. P equals 1. K we're trying to find. Cube root of q, cube root of 64, and the cube root of 64 is 4. So we get 1 equals k over 4, so therefore k must be equal to 4. So put that back into our equation, we got p equals 4 over the cube root of q.